Okay, sup guys, welcome to today's class. Today we are gonna continue the assembly school. A lot of people have written to me and told me that they really wanted me to continue this series. And I haven't done an episode for 6 months, but I promised one of my viewers that when I reached 20,000 subscribers, I would continue this series. So that's what I'm doing now. Alright, so today we are going to focus on conditionals. So basically, if statements. A couple of changes since the last episode. Instead of coding in a 64-bit environment, I will be coding in a 32-bit operating system. So not much will change since we were already writing 32-bit code, but the compilation step changes a little bit. And I recommend you to install a 32-bit Linux machine, because for some projects it will be much easier. Alright, and also I'm not going to be coding in VI today, I'll be using VS Code instead. Alright, so let's begin by creating a file. Let's call this conditionals asm, and I will set up the basic structure. So first of all, I will export the start label. I will have a data section, and I will have a text section for my code, and right here I will have my global label. Alright, maybe we should do this. And let's also begin by defining an exit label, where I will simply do what we did in another episode. I will simply move into EX a 1, into EBX 0, and let's do it like this for now. I will show you a better way later on. So just to recap, when we execute system calls like exit and system calls, they are functions inside the operating system in the Linux kernel in this instance. So first we put the system call number inside of EX, and 1 is exit. Then we put the arguments into EBX, ECX, EDX, and so on. And since exit only has 1 argument, we will put it inside of EBX, and I will exit with a 0 exit code. I will also do this. I don't have it installed, but that's a good exercise, by the way. There is a add-on for VS Code for NASM. So if we search for NASM, no, not that one. Syntax. We want the 32-bit. Let's see. x86. This is the one, I think. I will install this one. And now, if I were to go to, let's see, where did my files go? Here. Now we have syntax highlighting, so it makes it a little bit easier to do this kind of stuff. Alright, so now I have saved that file and it should automatically have uploaded to the server, yes, through Sociopath. That's my SCP client. Which has a feature that will automatically let you edit files on a Linux server with VS Code. Alright, so let's assemble this to begin with. I will do NASM, and I will make it an ELF binary, and I give the file name. So now I have the O file, and now I will link it accordingly, like so. No. Conditionals O dash O. Cannot find entry start. What did I call it? Global. That's a little lame. Alright, so this should be called start, of course. So let's do this again. I will run the NASM command and the LD command, and this time we get a binary. And if we run it, nothing seems to happen, but if we were to echo the return code, we will get something like 0. Alright, so now we have a starting point, but what did I say we were going to talk about today? Conditionals, right? And there is no if statement in assembly. There is, however, some similar feature. Let's say, for example, that we have a value inside of EX, which is 55 in hex. And we want to do a check if this is true, if the value is 55. What we can do is combine several instructions in order to obtain this result. So the first one we do is we use the compare. And it takes 2 arguments, usually a register and a value, but it can be 2 registers or whatever. So in this case, we are basically checking, is EX 55? And what shall we do in those cases? So first of all, we need to define a label. So let's call this true. So what we can do is using the jump conditional instruction. So there are a couple of those. JE, for example, it stands for jump if equal. And then it takes a memory address or a label, which is the same thing. So in this case, it will jump to this true label if this value is 55. By the way, let's put this true here instead. So we've set EX to 55. We check is EX 55, and if it's equal to that, we will jump to true, which means we will skip this. Okay, that's not what I wanted. Let's move these around. So let's put this there and this here. Okay, so if it's true, we jump over this label which sets the EBX to 0, and we go directly into those two. But if it's not true, then we will just continue on, which means we will set EBX to 0. So let's set it to some other value up here, like, I don't know, something like 1, 2, 3, 4, 5. I'm not sure if it's possible to have this kind of big values, but let's try it. Right? I mean, the register will hold this value for sure. I was just talking about the return value of the exit system call. Alright, so to recap, first of all, we set EBX to 1, 2, 3, 4, 5. We set EX to 55. We check, is EX 55? If so, we jump over this instruction and execute those two. Otherwise, we just continue through. We set EBX to 0 and then we run those two. So basically there are two possible outcomes. Either we exit by the 0 exit code, or we exit by this 1, 2, 3, 4, 5. So let's compile this. We have the NASM, we have the LD, and we run this, and we check the exit code as well. $69. So we did not get a 0. So why do we get 69? That's probably because it, as I mentioned, it probably has a value from this range, and it will just loop through when we have a big value like that. Okay, I think, however, if we run strace, yeah, in this case we can see the entire thing, because this value is probably 1, 2, 3, 4, 5 in hex. Yes. Alright, so this works as intended. Let's try changing EX to 54 instead. In this case, this will not be true. So we will not make this jump. Instead, we will set the EBX to 0. Let's assemble this and let's link. Yes, this time it's 0. And this is the only type of conditionals available in the CPU, so in assembly. There are, however, a lot of different jumps. So this is jump if equal, then we have jump if not equal, we have jump if less than, jump if less than, jump if greater than, jump if 0, and a couple of others. And how does this work under the hood? When we do this compare instruction, what really happens is it tries to do a subtraction. So it doesn't alter the register, but it does do a subtraction between this and this. And the result of that subtraction, it will alter a register called E flags. So E flags is a register that every bit is a on and off boolean for different things. So for example, there can be a 1 or 0 for a bit. That means that the result of the operation is 0. So if this is true, then jump 0 will jump. And then there is a carry flag. I don't know how to spell that correctly, but I think like this. So basically, when you do like when you plus, let's say 200 and 200 in a byte-wise add, then it will not fit inside of the that part of the register, and then it will set the carry flag. So we know that it's like when you do the addition by hand, pen and paper, then you put the carry on the top when it's a big number, right? And what else? There is a couple of things inside of here which relates to decimal numbers and a whole lot of different things. But usually we don't have to worry too much about that, because we just want to make a comparison, and then we want to jump depending on that comparison. So we don't really read or write or check the E flags, we just use this instruction. And often you will see something like a jump 0 instruction like this, and then a regular jump directly after that. So let's say we have this, if we have jump if equal true, then we might have a false label as well, and we jump to that false label. So basically we have two labels, one for true, one for false, and we make a jump if this is true, then we go there, and if it's false, we go there. So it's like if and else. And this no up here is not really necessary. No up is a no operation. It basically does nothing. But I usually do that, and a lot of people usually do that when you do a jump, you don't want to jump directly to the next instruction. You do want to have at least a no up in between. That's probably most by convention. I don't think it really carries any side, what's the name, any drawbacks. But that was just a little parenthesis. This is usually how I will do it in this series. So what have we learned today? We have learned that when we do a conditional, we first use the CMP instruction to compare two things, like two registers, or a register and a value, etc. That will alter something called the E flags register, which will tell the CPU that when you do those conditional jumps, it knows if it should do it or not. So in this case, we check if EX is equal to 55. If it is, we will jump to true over here. Otherwise, we'll just go through to the next instruction, which is this. And there are a couple of those jumps, like jump if equal, jump if not equal, jump if greater than, less than, 0, etc. So, that's basically it for today, guys. I hope you liked this episode and that you will watch the rest of the series. So please subscribe if you like this, so you can easily see when I will release my next episode. And also put a like if you like this episode. Thanks for watching. Thanks for today.